Okay, so we're gonna continue. Someone else got it. Here we have example number 6. In example number 6, we're going to use log to help us solve an exponential. So we're going to convert our exponential into a log. So remember, when you're converting a log, it's still going to be the same base. So it's going to be log base 8. 8x minus 3. And I'm going to take the log of the other side, because what I do to one side, I have to do to the other. So now I'm taking log base 8 on both sides. When you take property here, this is the identity property for logs. If you take the log of an exponential of the same base, they basically cancel each other out. So we're left with just x minus 3 equals log base 8 of 26. Okay. And then to get x by itself, I need to add 3. And what I do to one side, I'm going to do to the other. So that gives me x equals log base 8, 26 plus 3. Okay. If this is on the non-calculator side, this is what you would write. This is your exact value. Okay. And you would be done. Okay. If it was on a calculator side, that means they're expecting you to approximate. So you would plug that into the calculator as so. Log base 8, 26 plus 3. Remember, you can press math arrow up twice, and you can put in the log base, and it comes out to be 4 and 5. 5, 6, 6, 8. Okay. All right, here we're going to do an example where we're going to use natural log. So we're going to take the natural log of both sides in order to free our exponent over here. So when I take the natural log of e to the x, what I do to one side, I'm going to do to the other. Natural log of pi 1 plus x. Okay. So taking the natural log, now, again, these are identity properties. They're going to basically cancel each other out. They're inverse properties. I'm sorry, they're inverses. So they're canceling each other out. So we're left with x equals, and I'm left with 1 plus x. I'm going to use the power property. It becomes 1 plus x. Let's see. Thank you. Natural log of pi. Okay. And now I need to get all the x's to one side and all non-x's to the other side. So I'm going to distribute the natural log of pi. So I'm going to distribute. You get a natural log of pi. You get a natural log of pi. So we get x equals natural log of pi plus x natural log of pi. All terms with x are going to move to the other side. So when I move, I'm going to subtract x natural log of pi. So I'm left with x minus x natural log of pi equals natural log of pi. I don't know what I was writing there. Equals natural log of pi. Okay. I'm going to factor out the x. I'm going to factor out x. And when I factor out x, I'm left with 1 minus natural log of pi equals natural log of pi. So therefore, x equals the natural log of pi divided by 1 minus the natural log of pi. This again is my exact answer. So this would be, if I was on a non-calculator side, this would be your exact answer. If I had a calculator, then I would just put that in the calculator and approximate. And my approximate value would be -7 and 9. Something like that. Okay. So again, if you have a calculator, then more than likely you're going to approximate. Okay. If you don't have a calculator, more than likely they're just looking for the exact value. All right. The last part of this section is to talk about how to put this in the calculator. Now, if you have a calculator, it kind of makes things super duper easy. To solving by graphing, all you're doing is using your graphing section. You're going to put the left side in as your y1. You're going to put the right side in as your y2. And then you're just going to adjust your window. You have to be able to see the intersection, okay? So you have to see where, so this is key, adjusting your window, because you have to be able to see where they intersect. So after you do that, then you're going to press second. What do we press? I just had a break part. second. You know what? Let me just look at it. Here's Sylvie. There she goes. Second trace. I don't know why that was not coming to my brain. So you're going to press second trace. Second, and then you're going to press trace, and then you're going to press intersection. So second, trace, intersect. And it's going to ask you, are you sure? Enter. Are you sure? Enter. Are you sure? Enter. Okay, so you're going to press enter literally 3 times. Okay, so I'm going to model that for you. I'm going to clear Sylvie. So we have second plus 7, 1, 2. And then I'm going to go to y equals. I'm going to put in my left side, which is 2 to the 3x. So 2 to the 3x is my y1. I'm going to put in my right side, which is going to be my y2, which is just 9. I'm going to go to graph. And notice how when I go to graph, I can't see where they intersect. So I'm going to go to window and I'm going to adjust my graph. I mean, I can't see, never mind. I was like, I can't, but I can. I can see where they intersect. If I couldn't, or if I want to zoom in more, I'm going to go to window and I can say, okay, I want to be able to zoom in a little more. So instead of going all the way to -10, let's go to -4. I know that x has to be less than 4. Like we can make it 5, not 45. Count by 1. I know that my y minimum doesn't really matter because it's not going to go down there. So using some of your like knowledge of where things should be and how they should fall, you can go to 10 if you want. On the notes, this to go to 15. It's just more of a for the view of it. Sylvie, you know, she draws a little slow. So there's my exponential. And then here comes my constant. And I want to find their intersection. So I'm going to press second, trace. And then you see where it says intersect. I'm going to press 5. And it's like, is this your first curve? Yes. Is this your second curve? Yes. Do you really want to know? Yes. And you hit enter and it tells you. So it tells you right here. Boom. There you go. This is where it intersects at 1 and some change. Not just some change, but so now I know x. So now I can say the value of x is approximately 1.0566. 1.0566. That's gonna be my approximate value. Okay, and that's it as far as with the calculator. And then over here, if you are doing it by table, you're basically trying to look and see where their values are close. So you would change your scale factor for your table setting, but I really would encourage the table setting because it just makes more sense to find the intersection, in my opinion. And that concludes this section.